Whilst I'm talking, you should open your R Studio. You may not have to open it now, actually. Maybe you will start opening it in 1 hour time. Let's just say 1 hour time, okay? Oh, my screen is frozen. Ladies and gentlemen, I want to welcome all of you here to the Valley of the Shadows of Research Methods. Last time we looked at data. Today we want to look at the deeper aspect of ratio data. And this is known as hypothesis. Please write as much as you can. There are so many things I'll be saying here. The more you are writing, the best your chances. So I implore you, write anything you hear. What is a hypothesis? A hypothesis is a claim. It is a conjecture. It is a statement about a population parameter. It is a statement that comes from an authoritative source. The authoritative source holds the statement. If Kakubako should say that NDC will win the next election, and the Electoral Commission should say NDC will win the next election, which one will shake the nation? The one from Kwaku or from the EC? Pick. If you are not usually quick, at some point you say that I'm going too fast. That's why sometimes I ask you a question. Dana.
Yes, Prof. I think the one from the Electoral Commission.
Very good. Because that is authority. The null hypothesis is the authoritative statement. There are two kinds of hypothesis. The first one is known as the null hypothesis. It is represented by H naught. Write it down. The second one is the alternative hypothesis. It is represented by the HA. The null hypothesis is authoritative. The alternative is a mirror image of the null, more or less like the opposite. You see, you can take a sentence in your research and you can convert every sentence into a question. And you can convert every question into a sentence. When it is a sentence, it is a hypothesis. When it has a question mark, it can be. So let's take an example here. Here you have income has a positive effect on consumption. It's a statement. It's a hypothesis. Who can convert this statement into a question for me? Who can convert it into a question for me? One. Dinah.
Yeah, Prof, does income have a positive effect on consumption?
Perfect. Are socially responsible firms more profitable? Are socially responsible firms more profitable? Who can convert this into a statement for me? Who can convert this into a statement? Class rep, are you here? Solomon?
Yes, Doc, I'm here, please.
Okay, go ahead.
Yeah, so social responsible firms are more profitable.
Perfect. Give Dinah 2 marks for me. Write it down.
Okay, noted.
Let's move on. Next, because we have the null and alternative hypothesis, it's very important to know the steps in hypothesis testing. I'm about to give you the major steps in hypothesis testing. Please write each one of them because there's already a question on it. There are 4 steps. Step 1, write it down. State the null and alternative hypothesis. State the null and the alternative hypothesis. That is step 1. Step 2. Step 2. Choose the level of significance. and determine the p-value. Choose the level of significance and determine the p-value. In fact, you can switch some of them. There's no direct. Step 3. Compute the test statistic and the critical value. Compute the test statistic and the critical value. Step 4. Decide and conclude statistically and practically. Decide and conclude statistically and practically. We will go through these steps as we move on. But I want to just put on record the difference between the p-value and the alpha. Anytime you are doing a research, you are allowed to make mistakes. It's allowed. Because you're a human being, you're prone to mistakes, you can make mistakes. You might write your hypothesis, you might write your proposal, you might realize along the line your proposal is not correct, you have to change it. You can make a mistake. In the data collection, in the data imputation, you can make mistakes. The mistake you are allowed to make is an alpha. The error that you are allowed to make is an alpha. And this alpha is called a level of significance. That is an error you're allowed to make. The alpha, the level of significance. Who can tell me then, practically, what then is the p-value? If the alpha is the error you're allowed to make, what do you think, in opposite terms, what do you think is the p-value? Just say what you think. It's a deep question. The p-value is the error you actually make. Alpha is the error you are expected to make. So sometimes we call alpha the expected or allowed error. The p-value is the actual error. So which one do you think that we want it to be smaller? Is it the p-value or the alpha? Which one do we want to be smaller? P-value or alpha?
The p-value.
P-value. So that when the p-value is smaller, you can have enough gravitas to reject the null hypothesis. You see, the whole idea is to reject the null hypothesis. The null hypothesis is authoritative. You want to squash it down. So you go and gather, do data collection, calculate some analysis and all of that. And then you can come back and say, hey, what you said is wrong. So sometimes some people make very strong statements in the media without hypothetical testing, without subjecting that statement to statistical torture. You will do that. You will subject it to statistical torture here today. So these are the 4 steps. So understand the meaning of the p-value and the alpha. We always compare the two. What then is the difference between the test statistic and the critical value? The test statistic is the information gathering number. Is the information gathering number. Is a number you obtain from the information you have gathered from the data you collected. So the data you collect, you got to come out with a number, a statistical number, a representative number. Why? Why do you do that? Because the essence of statistics is to be able to make a statement about the population. You want to make a statement, a conclusion about a population parameter. And this statement, it is so big statement you're about to make. You see, the population itself is not known. is so large. And so what you do is that you take a sample from the population and you compute a statistic, the mean, the median, the mode, the standard deviation. You can compute each one of these things. And then after that, what do you do? After that, you can now use this statistic in the hope to represent the population. But the question is that, is it representative of the population? You need a benchmark. You need a benchmark that will help you to be able to say that what I got matches what is the standard. You see, that standard, that benchmark against which you check your test statistic is what is known as the critical value, sometimes called the p-value. So the test statistic is the information gathering number. The critical value is a standard or the benchmark against which you check the test statistic. The benchmark is something that you don't really have to go a long way to calculate. It is already there. It is obtained from a table. So sometimes it's even called a tabulated value. Okay. Yeah, Dana.
Please, you are going a bit too fast. I didn't get what you said about the benchmark
I said
portion.
the critical value is the benchmark. It is a standard against which the test statistic is compared. Ruth.
Yes, so please, you said that the critical value is the same as the p-value. I don't know
No,
if
I never said that.
Oh, you made that statement. That's why I'm a bit confused.
I never said that. I will never make that statement. So it's because they are all singing in your ears.
Okay, all right, thank you.
The critical value is the benchmark or the standard against which you compare the test statistic. It is a calculated number. As for p-value and that of the alpha, the level of significance, I finished them. I said they are all errors. I said that before. Guys, if you don't write everything I say, you will get lost at some point. So it's very important you are writing and writing and writing and writing and writing. If you are engaged in something right now, you are losing big time. I beg you. See, that is why this very time has been dedicated for this purpose. Okay. So now we are going to take a couple of examples and look at situation. But I want you to take note of some few things. Number one.
Thank you very much. I'm entering for this.
In hypothesis testing, it is important to recognize that you need to learn how to write the null and the alternative hypothesis. There are some symbols that go with the null and the alternative hypothesis. Some of the symbols are less than. Who can tell me the opposite of less than? Please, the first answer that came to your head is wrong. What is the opposite of less than?
Greater than or equal to.
Very good. And the opposite of greater than is less or equal to. The opposite of not equal to is equal to. Write them down. Write them down. Write them down. Be used to writing them down. As you write things down, there's an information symmetry between your brain and your hand. Yes, Ruth.
Please, can you repeat the opposite of the equal to and the less than and greater?
Do you see my screen? Ruth, do you see my screen?
Okay, please, I'm just seeing it.
Everything I said is written down. So In hypothesis testing, opposite of not equal to is equal to. And opposite of less than is greater or equal to. Opposite of less than is not greater than. It's greater or equal to. And when you watch the videos I've made and the note again, you will see these things. Okay. I've done a whole lot of video on this, which is on the channel. So take note of that. Normally, these ones are called one-tail test. The less than, the equal to, because it's one direction. Okay. For example, if you say that she is less than 30, she can never be, more than 30. It's one direction. The opposite of that is that she's either going to be 30 or more. So the directions are, but if you say that she is not equal to 30, that one, the opposite will be either she's going to be less than 30 or she's going to be more than 30. So that one, the direction is 2. The direction is 2. So these two symbols, the equal to and not equal to, they are usually for two-tail testing. Two-tail testing. Good. On the basis of this foundation of hypothesis testing, you can take a sample. Let's say you can take the ages of everyone in this class. The ages of everyone in this class, some are 20, some are 24, some are 52, some are 40, some are 43. If you take the ages here, this sample is a one sample, one. And so the test statistic you will use is known as a t-test. T-test. But when the samples are 2, so this time you can say that you want to check the ages of girls in this class, and then you can also check the ages of boys in this class. So this time you are comparing, isn't it? You're comparing the ages. And so you have the ages of boys as well. This comparison is a 2 sample. Now you have a 2 sample. Check the notes and check the video. I've explained detailed the difference between a 2 sample and a 1 sample and the test statistic needed for each one of them. In fact, I want to show you something. So you should know what the difference between 1 sample and a 2 sample. You should know the difference. Okay. This table, you should memorize it if possible. It is in many places in your slides. It's in week 2 slide, it's in week 3 slide, it's in week 4 slide. So it's there, this table. It talks about different types of test statistics that are used to assess depending on the sample. And the test statistics are 2. One of group is known as parametric test, the other group is non-parametric test. The difference between the two is simple. The difference between parametric test, and please note that down, the difference between parametric test and non-parametric test is the word normal or normality. Normality, write it down. When you have a data and the data is normally distributed, such a data is said to be parametric in nature, and therefore you need a parametric test for it. When the data is normally distributed. Now, what do we mean when we say a data is normally distributed? Well, what we mean is that majority of the data points are in the center. So sometimes we use this symbol called a bell-shaped curve, where majority are within the center. For example, right now, most of you here, your ages are normally distributed, your salaries are normally distributed, your heights are usually normally distributed, your weight are usually normally distributed, Even though there will be some older ones, there will be some millionaires among you, okay? But these are a few outliers. The majority of the people in this class Their ages are normally distributed, their height are normally distributed, their weight are normally distributed, their income are normally distributed. And this is the way you want to understand normality. Anytime you are looking at a sample and the data is normally distributed, the test you use is known as parametric test. That's it.
Hello, Prof.
Yes?
Sorry, please, if you could kindly take that again.
I should take which one again?
The normality.
Normality.
Yes, sir.
When the data is normal, it means that majority of the points are in the center. A perfect normality is where the mean is the same as the median, is the same as the mode. The mean is the same as the median, is the same as the mode. Tell your colleagues to join the class. The moment it is 7:30, I'll close the door. I'll block people from, well, they have to be on the waiting until I allow them. So when the mean is the same as the median, that's perfect normality. In such case, the tests you use are parametric tests. If not, and this is skewed, for example, this one is skewed to the, maybe to the left here, and this one is, say, skewed to the right here. Then in this case, what it means is that it's not normally distributed. It's skewed. It's non-normal. In such a case, the test you will use is known as non-parametric. So every parametric test has got its non-parametric equivalent, its non-parametric version. Learn them. Learn each one of them. Know the parametric equivalent of any non-parametric test, and know the non-parametric equivalent of a parametric test. Today, we are going to look at one of these hypotheses. There are several of them. We're going to take just one of them and look at it. And that is known as ANOVA, analysis of variance. ANOVA, analysis of variance. It will bring home most of the things we are going to be doing. So let's take ANOVA. One, there are a few things you need to know about ANOVA. The word ANOVA stands for analysis of variance. Who can tell me the meaning of the word variance? What does the variance here mean? Variance. Give me another word. Variance.
Said difference.
Difference.
Difference. So what ANOVA is for samples that are 3 or more. Write it down. ANOVA is for 3 or more samples. Of course, you must have seen it in the table. Okay. 3 or more than 2. Another way of saying it is 3 or more than 2. Remember, we are looking at samples where the groups are independent of each other. They don't know each other. They don't know each other. The groups are independent. But where the groups are dependent, we call it repeated ANOVA. What do you mean by when we say the groups are independent? Okay, suppose I take the ages of 3 groups. So I can say that I'm taking the ages of all those working in the financial institutions. Their ages here. Finance. All those working in the educational sector, their ages. And then all those who are working in agricultural and manufacturing related sector. So you see, we have 3 groups here, and they are not related to each other in any way. When I say not related, it's not the same person here who is the same person here, no. However, you can have a situation where you record the marks, okay? So you have maybe Kofi, you have Kojo, you have Ama, and then you record the marks of Kofi before the exams, okay, or let's say before IA, before the interim assessment. So you record the marks before IA. Then you record the marks during the IA. Then you record the marks after the IA. It's the same person. Kofi had 80 before, he had 82, and then he had 64. It's the same Kofi you are recording his marks. So the samples are 3. You have IA before, IA during, IA after. For Kofi, for Ama, for each one of them. And these are 3 different samples, but they are related because it's from the same subject. Such a sample is dependent or repeated sample. Dependent or repeated. We are not looking at that one today. The one we are looking at is the independent, the first example I gave. Let's take a real example of that. So let's take an example like, so all of these are examples. Okay. Now, if you look at this one here, is this dependent or independent? Take a very wild guess based on knowledge, calculated guess. If you look at this, this is a drag, and you have person. You have a Kuya, Bakon, Chidi, Doji, and Ifua. And then you have some recorded drugs here. Do you think this is dependent or independent?
Dependent.
It is dependent. That is true. Perfect. Now, so all of them are dependent, and there are several examples of dependent and independent. So get to know. So we're going to take an example, and then we are going to look at the following. We're going to take a real life example that requires ANOVA. I want you to write this table down and write the numbers also down. Write the table down. Below are the salaries of thousands of Ghana cedis, in thousands of Ghana cedis for 3 MBA groups. These are their salaries. You have the regular MBA, which is our MBA. They earn 1,000 cedis, 2,000 cedis, 3,000 cedis. Weekend MBA students earn 4,000, 5,000, 6,000, thereabout. EMBA earn 7, 8, 9,000, thereabout. This is just hypothetical. The question you are being asked is this. Define the null and alternative hypothesis. You're going to do that together. Find the critical value of the test statistic. Find the value of the test statistic. Decide, and then answer a few questions. So let's go to this data set. So what is the question really telling you to do? Well, watch the question carefully. The most important part of the question is there a statistically significant difference? Keyword, difference. Is there a statistically significant difference between the mean? Keyword, mean. Between the mean salaries of these 3 different MBA groups. Is there a difference? Is there a difference? In order to check whether, okay, there might be differences. Maybe the EMBA are earning highest. Maybe the weekend MBA are next. Maybe the regular MBA are the poorest. But the question is that, whatever the difference is the difference statistically significant? Write that way down. Is the difference statistically significant? For example, you can have your friend, okay? Your friend is, 5'5" in height, and you are 5'7" in height, or 5'6". He is 5.5, you are 5.6. And your friend is shouting, I'm taller than you are short, Papa, you are short. I've never seen a shorty like you. You are kutubo. You are kutubo. Okay? And the person is really, really. And so you said that, but you're not that tall. You say, what? That meter I have more than you is not a joke. It is significant. As to whether what a person is saying is true or false, has to be subjected to statistical torture. ANOVA will do the work if the people are made. So the whole idea is to check whether whatever the difference is significant. For example, EcoBank makes $12 million. GCB makes $17 million. SG Ghana makes $13 million. Is the difference across these, these profitability differences, is that significant? Is that significant or insignificant? That's what Anulomwa is trying to do. So these salaries, the question we want to know is whether that is significant or not. So let's look at the first step in hypothesis testing. The first step is to formulate the null and alternative hypothesis. Pay attention because I'm going to show you how to do this. How do you do that? Well, the first thing you got to do with any analysis of ANOVA, any ANOVA, the first thing you have to do is what I'm about to show you. You will write the word HO. Who can tell me what the HO represents?
Null hypothesis.
Null hypothesis.
Then you will write HA.
No.
What does HA
No.
do?
Alternative.
Now, the information you are being asked here is about the mean. The symbol for the mean is mu. Mu. Like mu. Mu. What you got to do is recognize that the samples are 3 in this context. And therefore, each one of them is going to have a population mean. This mu is not a sample mean, it's rather the population mean. Write this down. We always use the population mean to write a null hypothesis. We always use the population mean to write the null hypothesis and not the sample mean. Not the sample. So, we're going to write the null hypothesis. All you have to do always is to write mu1 for the group 1 equal to mu2 for the group 2 equal to mu3 for the group 3 because there are 3 groups. And then the alternative, always write it as mu I not equal to mu j. For at least, write it down, for at least one I, for at least one I or j, where one I or j, where I is not equal to j. For at least one I or j, where I is not equal to j. That is how you do it. You write this down. I'll explain it. Write it down. Now, ladies and gentlemen.
Sir.
Yes.
Please, what you are saying is actually a little different from what you are writing on. As you said, where I is not equal to j.
Oh, sorry. Where I is not equal to j. Thank you. So in other words, any sample, which is sample I, is not the same as sample j. Now, the first one is clear. What does the first one say? In simple language, what the first one is saying is that there is no difference. Write it there so that you know the English meaning of what you wrote. This first one is saying that there is no difference in their means. No difference in the population. No difference in the population. Write it down. No difference in the population. Write it down. Yeah. Write it down. No difference in the population mean. Write it. So what this is saying, and what the null is saying is that if the mu1 is 50, what is the mu2? The null is saying that if, sorry? If the mu1 is 50, what is the mu2?
50.
It's also 50.
It's also 50.
50.
So the alternative is saying that you just need one of them to be different from another one. So it can be that the alternative can be that mu1 is the same as mu2, mu2 is the same as mu3, mu3 is the same as mu4, mu4 is the same as mu5. But just that mu 5 is not the same as mu 6. And that alone will cancel everything. So then now the alternative is saying that you just need one of them to be different from the other. You just don't need all of them. You don't need mu 1 to be 50, mu 2 to be 60, mu 3 to be 63, mu 4. No, you don't need all of them to be different. Oh, no. You just need one to be different. And when one is different, that is the alternative. I have a question for you. So what is alternative saying? The alternative is saying that at least we just want one to be different from the others. Who can tell me how you would have written the null? Oh, by the way, never write the null hypothesis without this column. Always bring the column. Oh. Null hypothesis without column is 0. If the groups were 5, who can tell me what would have changed on the screen? Raise your hand and walk us through. If the you need to also add here. Hey, in this case, I forgot to. For at least one ij, after this one ij, you should add, in this example, the groups are 3, so you write 1, 2, 3. Okay. For at least one ij, 1 to 3, where ij is not equal to j. I is not equal to j. So bring one I, comma j equal to 1 to 3. If the groups are 5, who can walk us through how to write a null and alternative hypothesis? It's just changing something small. Who can raise a hand? Let me see the champion of champions here. If the groups were 5 groups instead of 3 groups, what would have someone?
Say, where the I to I or j is equal to 1 to 3, you make it I or j is equal to 1 to 5.
Okay. Is that all? All right, let's go to Ima. That's wrong. Ima, polish it.
Sir, please, it's Emma.
Emma, yeah, go ahead.
Yes. So it will be the same thing as mu 1 is equal to mu 2, which is equal to mu 3, is equal to mu 4, is equal to mu 5 for the null hypothesis. Then the alternative will be mu 1 is not equal to mu I is not equal to mu j for at least one I j, which is equal to 1 to 5, where I is not equal to j.
Perfect, 100%. 2 marks for you.
Thank you.
That's how you write the alternative. These are the people you should befriend. People like Emma. You should befriend them. Not the one you have been befriending. Yeah. Okay. So that is how you write. Now, you might get 4 groups or 5 groups or 6 groups. So learn how to write the null and alternative hypothesis. Okay. The step 2. Who can remind us of step 2 in a hypothesis testing? In fact, I swapped them, but make the step 2 finding the critical value and then the test statistic. Okay. So for this very purpose, make step 2 find the test statistic and the critical value. That's what we are going to do now. Find the test statistics and the critical value. Now, to be able to do this, you need to generate something we call the ANOVA table. Write it down. I'm going to show you the ANOVA table. The ANOVA table is just a matter of writing a small table like this and then splitting it like that. Here, you should have something like source. You should have something here called source. Write this table. And under source, you should have between group differences and then within group differences. Between group differences and then within group differences. Good. The next thing is to have something known as sum of squares. sum of squares. The next heading should be degrees of freedom. The next column should be mean squared, and the final column should be the F statistic. Write it down, write it down, write it down, write it down. Our goal is to fill this table. By the time we finish filling the table, our job is done. Simple. So anytime you're doing ANOVA, you should create this table to make life easier. Okay. So the second column, first, let's look at the first column, source. Source means that, look at the word ANOVA. The word ANOVA is analysis of variance. Variance means differences. Differences. So when you look at the first column, it says between group differences. That's a BG. Between group differences. And the second row is the within group differences. Now, is that true? And the answer is yes. Between RMBA and WMBA and EMBA, between them, there are differences in the salary. Do you agree with that? Between them. Do you agree? Within each one of them too, there are differences. So when you take RMBA alone, there are differences within RMBA. Because there's a difference between 1 and 2, 2 and 3, and all of that. When you take the EMBA, there's a difference between 7 and 8. And please remember, these numbers are small for a purpose, just for you to understand. Real life will not have be like that. Okay. Once you now notice, so what we are going to do is that we're going to take care of every difference. That's the whole idea. We are analyzing the differences. We are going to analyze the differences and then come out with a statistic that shows the clear differences. To do that, we need to find something here which is known as SSG. Write it down. Maybe you need to create another table, SSG. We are going to fill in that column. So the whole essence is that we are going to create something here and fill this box. And create something here and fill the next box. Fill this one, fill the next box. Fill this one, fill the next box. And then finally, we will have our F statistic. So this is what we are trying to do right now, right here. So the first box is known as the, and again, all of these are in the note and in the video. Check it under ANOVA. The first column is known as SSG. Now let me write the formula here. What is the SSG? The SSG actually stands for the group sum of squares. It is read backward, the group sum of squares. Now let me give you the formula by just going to the slide up here, just so you feel what it is. Okay. So this table I did is the same table that is here. So let's look at the SSG. This is the SSG. This is the SSG. You might not see it, but I'll write it properly for you very soon. That's it here. Good. So we're going to write the SSG. How do you write the SSG? The SSG is actually equal to summation bracket X I J minus X I bar minus X bar all square. Write it down. X is very easy. When I interpret for you, you see that it's very easy. X I bar minus X bar all square. Summation of that. Basically, what it is saying is that, oh, by the way, let's try to, and this starts from, I starts from 1 all the way to n. So I starts from 1 all the way to k. I starts from 1 all the way to k. Or j In fact, let me just confirm the formula. All of these formula will be given to you, by the way. But you should know it so that at least. Yeah, I starts from 1 all the way to K. So look at it here. I left one thing. Yeah, sometimes you'll always be tempted to leave something. So take note. So there's something here called N. So you have here, in here, there should be NI. NI. So summation NI. Summation NI is the other one that does not have the NI. When you check in the table, you see what they mean. But let me just give you what it means. NI here is talking about the sample size in each group. So when you go to RMBA, what is the value of NI? What's the value of NI? Remember, NI is 3. What about WMBA?
3.
What about
3.
EMBA?
3.
Yeah, they are all easy. Now they are all easy. But sometimes you can have a situation where one is 3, one is 7, one is 9. But whatever it is, the NI refers to each of the sample size. The XI bar is referred to the mean in each group. The mean in each group. So you might want to write that down. That XI bar is the mean in each group. And then the X bar is the grand mean, the mama mean. It's not the mean of means, take note. It is the mean of all the observations. So you cannot take the mean in each group and then after that you find the mean of that one. No, it is rather taking the mean of all the observations put together. We'll come to that. So right now we are going to calculate the XI bar for each group. Remember, I is for each group, XI bar. So we're going to go to RMBA, we find the mean there. The WMBA, we find the mean there. Then the EMBA, we find the mean there. So let's start finding X1 bar. That is the mean in group 1. Who can tell me the value?
2.
2. Excellent. Let's go to the second one, X2 bar. This one, if you have mathematical, I don't calculate it. X2 bar. 5.
5.
Is 5. And what about the X3 bar?
8.
8. Did you calculate that or you check the center?
Take the center.
Yes. It doesn't mean that you always have to check the center to give you, else you will feel put off. What you do is you just have to calculate. In this very example, it was easy to know that the gap between the numbers is 1, 1, 1. So that one was easy. But in real situation, you have to sum them and then find the mean practically. Practically find the mean. Okay. Now, so we know the mean. Now let's find the grand mean, the X bar bar. Who can tell me the value of the X bar bar? Remember, the X bar bar means that you add the 1 to the 2 to the 3 to the 4 to the 5 all the way to the 9. And then when you finish, you sum them
5.
and then divide all of them by the sample size of 9. So that will give you, in fact, this one, if you have a critical eye, you will know. You see that it is 5. Okay. So you add all of this. When you add all of them, you get 45. Then you divide the 45 by 9, and that will give you 5. Therefore, the X bar is equal to 45 divided by 9. Write it down, which is 5. So now that we have these two, we are ready to calculate our SSG. So watch how we do it. I'm going to start with 1, and then I'll let you complete all and tell me the final answer. So the SSG here is going to be, look at it. It says take the sample in the first group. So in the first group, the sample is what? 3. So you write 3. Then you bring a bracket. Remember to square that bracket. Then it says that take the mean in that same first group minus the grand mean. The mean in the first group is what? 5.
2.
Very good. 2. The grand mean is what?
5.
5.
Then you square it. Then you do plus. You go to the second one, the second group. That is what? 3. Then you take the mean in that second group. What was the mean there? 5. Minus the grand mean. The grand mean was what? 5.
5.
Then you square it. And then you do for the next one. I want all of you to do and privately send me your answer. You have only 2 minutes. Privately send me the answer. I'm recording this for a purpose. If you miss it, you've lost 3 marks.
Plus the sample size 3 into brackets. What is the mean? 8 plus 5. Right. This is going to 3 times
You got 30 seconds to finish. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Stop. So you all know the answer, and the answer is 54. So when you did that, you got 54. So now we can calculate and say without a doubt that the first box here is 54. We have been able to get the answer to our SHG. We go to the next one. The next one, which is the section in the next box, is for the within group, and therefore it will be SSW. SSW here will stand for within sum of squares. And this is given by summation xij minus xi bar all square. That will be the formula. Write it down. And again, you have it in the slides, xij minus xi bar all square. Okay, so what does this mean? What it simply means is that, forget about the summation part. Let's deal with this. So it means that you take each number. Let me just wipe off some of them. You take each number here, and all you got to do, each number here is the xij. Okay, each number is the xij. So when you take something like this, 1 is xij, 2 is xij, 3 is xij, 7 is xij, 8 is xij, 9 is xij. Okay, so you're going to start with group 1. And then for group 1, you take each number there minus the mean in that group. The mean is the xi bar. So as an example, if I were to calculate SSW1, that is for the group 1, I would take the mean, I know the mean is 2. So I'll take each number minus the mean and square it. So the first is going to be 1, which is this first number, minus the mean, which is 2, I square it, plus 2 minus 2, then I square it, plus 3 minus 2, then I square it. That's it. That is for SSW1. Please do follow. And of course, when you add that, what are you going to get? When you add that and you do it, you're going to get a value of 2. Because first of all, the middle one is 2 minus 2, which is 0. 0 squared is 0. 1 minus 2 is minus 1. Minus 1 squared is plus 1. 3 minus 2 is 1. 1 squared is 1. So you add this one to the first one. That is 2. Actually, if you have a mathematical eye, you won't calculate it anyway. So we are ready now to find the SSW2. Find that, and then find SSW3. Find that, and when you finish, you add all of them together. That's why you have the double summation here. When you finish, you add all of them together. So the summation becomes double, which is SSW. And SSW will be the 1, the 2, and the 3 summed together. Who has finished? Raise your hand. Just raise your hand for me if you are finished. Madugu. Madugu, what's your answer?
Please, I got 2.
No. I'm talking about overall. Marvin.
Okay. Sorry.
6.
6. Who said 6? Marvin, right? But
6.
that, Marvin, you have 2 marks in my record. So when you do all, you should get a value of 6. In fact, the first one should be 2, the second should be 2, the third should be 2. When you add 2, 2, 2, you get 6. That's it. That's it. So we are now ready to write our second number in the box up here. So in the box up there, we can conclude without a shadow of a doubt that the SSW is equal to 6. In fact, the most difficult one is the one we just did. Everything else is easy. The SSW is the most difficult of all. You're done. The next is to find the degrees of freedom. The degrees of freedom. The degrees of freedom is for both the B gene, which is the between group, and then the W gene, which is the within group. Okay? The within group sum of squares, and then the between group sum of squares. Now the formula for them are there. When you come here, you see it. But I'll show you properly. So, what is this degrees of freedom? Degrees of freedom simply tells you how far you are being sympathized for having a smaller sample. So, what is the degrees of freedom? Well, the first one, which is the one in the box here, the numerator box, is given by k minus 1. So the box here is k minus 1. That's the first one. K minus 1. And the second one is n minus k. Write it down. K minus 1 and n minus k. We'll use these two to also find the critical value, the final step. Okay, so what is k? Who can remind us what is k? We used it earlier. What is the value of k? Daniel.
Number of groups.
Number of groups. So what is the value of k? Daniel. In this example. And therefore, what is the degrees of freedom for this numerator?
So 3 minus 1.
And what is that?
2.
2. So therefore, the degrees of freedom here is 2 for the first numerator. Who can tell us the degrees of freedom for this second one, the n minus k? Who can tell me the final value for the n minus k? The n minus k, the final value, Grace?
Please, 7.
7. That is not correct. Who can tell us the final value for the n minus k?
Is 6.
6.
Solomon.
6.
6, please.
Yes, it's 6. Because n is the total sample, which is 9. N is the total sample, which is 9. K is already the 3. So 9 minus 3 is 6. Therefore, we can say that the value down here is also 6. You don't know. You're left with just 3 boxes to fill. They are the easiest. So how do you find the mean squared here? This one is going to be the mean squared error. The mean squared error. Well, to find the value here, you just divide the SSJ by the degrees of freedom of the numerator. So, and again, it's in the formula up there. To get to the box here, you find the 54 minus the 2. And to find the second box here, it becomes the 54 divided by 2. And then the other box, it is 6 divided by 6. So who can tell us the answer for the first one? The MS.
27. 27.
And the second one?
1.
1.
Now, the final one here, the F statistic is the numerator answer, the top answer for the SSJ, divided by the down answer for the SSW. Therefore, what is the value of F?
27.
27.
That's it. This is 20 marks in the exam, by the way, just so you know. By the time you finish this, you got 20 marks. Now, why are we going through all this? We are going through all this because I want you to know what is happening in the software. I want you to see what is behind the scenes happening. Because when we come to the software, you see that is exactly what it's doing. Fantastic. So we have been able to now identify this whole element of this ANOVA, but we've not done, because this is the F statistic. So the F statistic is equal to 27. If you check the note, you see the formula. Anytime you find the test statistic, write it down. You have to compare it to the critical value. And I know you've written it already in the steps. Anytime you find the test statistic, you have to compare it to the critical value. What is the critical value here? Well, it's a very simple thing. The critical value is given by something we already know. The F subscript alpha, subscript K minus 1, subscript N minus K. Write it down. This is what is known as a critical value. This is the benchmark whenever you are doing analysis of variance. This is a benchmark. So remember, I told you once that you have to compare, take this value from the table. It is called critical value. Critical, because it is a standard. It's the benchmark against which you compare the statistic. We just got a test, the test statistic here. We just got a statistic. We are now looking for the critical value. How do you get that? Well, first of all, you need to know the values in the critical value formula. This critical value formula written down here is known as F critical. F critical. Depending on the accent you have, you can say X critical. X critical. What is alpha? Whenever alpha is not given, the default alpha is 5%. Write it down. Whenever alpha is not given, the default alpha is 5%. Now, in this very example, like in most examples I might give you, the critical value, the alpha is always the default of 5%. But remember, I told you what the alpha is. I told you the alpha is expected error. And actually, there are only 3 of them in the world, basically, that we normally focus on. 3. What are they? Well, the 3 that we normally focus on are 1%, 5%, and then 10%. These are the 3 we usually focus on. These are the errors you are expected to make. If you make 1% error, it means that you have already made 5%. In other words, sorry, if you make 10% error, you've already made 5% error or 1% error. Okay, but when you don't know which one to use, always stick with the default, which is 5%. So we are going to rewrite this F critical as, let's rewrite them. We are just substituting the values as we know it. So what are the values? The first value, the first letter is F, and the first Greek letter is alpha. Now we know that the value of alpha is what?
5%.
Exactly. So you write 0.05. Then you do comma. What is a k minus 1? We already know what it is.
It's 2.
It's 2. What is a n minus k?
It's 6.
6. That's it. So we already know this. So because this critical value is a benchmark, it's from the table, we are going to go to the table to find it. Ladies and gentlemen, to do that, I'll wipe out everything. Okay. So if you have your notes, you can look at the table here. It's also in the notes. Let me just use a minute to just tell you what the table. So this table is known as the F table or the ANOVA table. Okay, it has 2 situations. First thing is that you see that this one is 5% here. In fact, the actual table you will get in the exam, it has both 5% as well as 1%. So just the 1% is another table down there. But I decided to just show you the 5% because that's what I was using here. So when you are, for example, in an exam room, you have to open your eyes and know which table you are using because both of them are given to you. Okay. Once you have gotten that, remember that is what we used for the alpha. So you now have the value of the alpha to be 0.05. So now you take the 0.051 because that's the one that you have. Other than that, if it is 1%, you'll be told. If it is not 1%, but it's 5%, you will not be told, but you should know that it's 5% because that is the default. Okay. The next important thing to check in the table is the numerator degrees of freedom. Remember the k minus 1, which we found ours to be 2. And remember the n minus k, which we found ours to be 6. The 2 comes first because that's the numerator. It is always red at the top here. So you pick the 2 from the top. And then the 6, the next number, you always pick at the far left. You pick at the far left. Where they meet is your critical value. Where they meet is your critical value. Don't say it. Type where they meet. Type where they meet. The number for the 2 critical value, for the 2 degrees of freedom and 6 degrees of freedom. The junction number. Type your answer and let me see that what being an answer one. Yeah, actually be. Fantastic. But all of you are right in typing the answer to be 5.14. That is how you find the critical value. Now you are done. For ANOVA, I will not bore you guys to look for a p-value, okay? But I will give you that in the software. So show you that when we get to the software. So you are now ready to make your conclusion. Since you now have all the values. Okay, remember, we have 5.14. So let's go to the question here. This part says, find the critical value. We just found the critical value to be 5.14. This one was saying that find the test statistic. If you could remember, we found it to be 27. This one says, what is your decision? So we are going to make a decision. Okay. And everything has to be based on the null hypothesis. Okay. In case you've forgotten, the null hypothesis says there is no difference in the salaries. Okay. This was the null hypothesis, by the way. There is no difference in the salaries. The alternative says there's a difference. We have been able to find the critical value here. All these steps are done. We have been able to find the critical value here to be 5.14. Everything is in the note as well. And then we have also been able to find the test statistic. All these steps, 2, 5, 8, everything that we calculated, SSW1, SSW2, SSW3, SSW4, all of these things we did, I've shown you step by step for you. The table, okay, finding the answers, eventually finding the critical value, and finally finding the F statistic. This table is nicely generated for you. Now, what is your decision? That's the next part. Would you say there's a significant difference in the salaries? Well, here is a rule, decision rule, write it down. Whenever the test statistic is greater or equal to the critical value, whenever the test statistic is greater or equal to the critical value, we reject the null hypothesis. Whenever the test statistic is greater than or equal to the critical value, we reject the null hypothesis. So in short, what we are saying is that if F statistic is greater or equal to F critical, reject H naught. H naught is the null hypothesis. That's it. That's it. Reject H naught. So we need to check our critical value and our test statistic. Is our critical value, is our test statistic greater than a critical value?
Yes.
Yes, I agree with you. Should we reject the null or we don't reject the null?
We reject.
Yes.
Now, that is a decision, but that is not a conclusion. Deciding doesn't mean it's concluded. So this is a decision rule. And of course, we are using the 5%, so we always add that. Since the reject the null hypothesis at the 5% level of experience. But you need to conclude statistically and practically. How do you do that? So you say that statistically we need to conclude. And the conclusion was that, is there a significant difference in the mean salary? So you have to conclude practically and say that since the F statistic is greater than the critical value, we reject the null hypothesis, which is what? And conclude that, that's the thing, conclude that the mean salaries across the 3 MBA groups are statistically significantly different from each other. Let me repeat that. The mean, we conclude that the mean salaries across the 3 MBA groups are statistically significantly different from each other. Are statistically significantly different from each other. That is how you do your conclusion. So is there a difference? Of course, because the null was saying there is no difference, don't forget. The null said there is no difference. That is what the null hypothesis was saying. The null hypothesis was saying there is no difference. The alternative hypothesis was saying, oh, come on, one of them is different. Well, we didn't have enough information to reject the null hypothesis, so we just have to accept what the null is saying. And the null says there's no difference. Oh, sorry. We just have to reject what the null is saying because we have enough information to reject. Because the test statistic is bigger than the critical value. Okay. So we reject what the null is saying. And the null was saying that there's no difference. There's no difference. They are all the same. Oh. The salaries are all the same. Oh. Now, checking what you have, the salaries are not the same. So we can conclude that the salaries are not the same. There is a clear difference. There's a clear difference in the mean salaries across these three MBA. There's a difference. So we can now address the question, if there is a difference, then which group is earning the least? Use the mean to answer the question. Who can tell me? Which group earns the least?
Group 1.
Group 1, RMB.
Exactly, RMB, group 1. Exactly, so they earn the least. And now you can say which group earns the least, which group earns the highest, because no matter how small it is, the statistics shows that there is a difference. Fantastic. We're done. Let's go to our R and our Excel. So please, at this stage, I want you to open your Excel or your R. Your R Studio, please open it. I'll give you a minute to open the R Studio. Masters. Yeah, for so. To me, Jai, anytime. But don't worry. Today, I'm not going fast at all, so I've gone so slow. So it should be fine. I hope you guys are getting the thing. If you're not
Yes, sir.
Yes, small.
Yeah, I like that word. Small. It has to be small. If it's not small, I'm looking for my Excel. Hold on. Now I got on my Excel so I can. So one of the things you have to note whenever you are doing ANOVA is open your R and then the R Studio. So I have my R Studio open, and I hope that you also will have your R Studio open. There is a data set I gave you. There is a data set I gave you. It's called Burukutu data set. Please open that if you have not opened. Hey, people are still joining. Can you imagine? People are joining now. Wow. Yeah, porno. Okay. So Burukutu data set. Guys, I'm going to do something very fast because I've done a video of it. We are using this portion of the Excel, but the data set is here. You can always run a lot of things on the data set. You can run descriptive statistics. Last time we did it. So try and learn how to run the descriptive statistics. Okay. Learn how to run the descriptive statistics. That's all. If you want me to show you how I can move faster here, Whilst your data, the descriptive statistics requires you to use the Brukutu Excel, not the Brukutu R. This is the Brukutu Excel. And to do that, you just have to go to Data tab at the top. On the far right, you do data analysis. I'm not going to repeat because it's been recorded already. That part is always on the channel. And then you click in the data analysis parameter dialog box, you click on descriptive statistics, double click, open it, and then come and highlight the entire data set from kill all the way to the end. Take all of them together with their headings and then put them into the input range. Then you check the labels, you check the output, actually choose a new worksheet, okay? And then call it DS for descriptive statistics or summary. Let's just call it summary. And then you click on summary statistics here. And you just click OK. It will create a new sheet. It will create a new sheet. There you go. It has created a new sheet. And that gives you your descriptive statistics. This time it will look a little bit complex. So click on the first one and move it to the one step right. Cut and then paste it in the next column B. And then after that, click on this and remove it. Control Shift, Control key down, Control key down, Control, because they are all having the same heading. Control key down, Control key down, Control key down. Your hand on the Control key must be held, all through. And then when you're done, you right click just one of them and do delete. It will do delete and then everything will now be proper. So for each variable, you will get the mean. So for this variable, you have the mean. Okay. For this variable, you have the standard error, the median, the mode, and all of that, which you should learn how to interpret. Okay. You should learn how to interpret. I told you I'll give you just one group assignment. It will help you in all of this. Okay, but what we are interested in is this one. Okay. This is a Brukutu R. This data set we are going to take into our R studio. So I'm assuming some of you have been taking pictures and posting it on the page. So I want you to open a new, when you open R, this is what you see. Okay. In order for us not to, we are going to have a new, a new sheet. So let's assume we have a new sheet here. Let's load the data. Call it gen. So type gen in the command. Gen equal to, I think this one I gave you. Read.delay. Okay. And then you do into bracket double apostrophe. And then inside a double apostrophe, you type clipboard. Fantastic. And then go and copy the entire data set in Excel. So click inside and do Control A. Do Control A to highlight everything. Do Control C to copy everything. Control A will highlight, Control C will copy. Okay. Now come here, click anywhere here and do the run at the top or do Control Enter. Do the run at the top here or do the Control Enter. You do boom, everything shows in blue down here, which means the data is loaded. To prove that the data is loaded, you can highlight just the gen and run it again. Just the gen alone and run it again. Or you can type gen and just Control Enter. The data will be showing down here. Okay. That's what you see here. Fantastic. Okay. Now, what is this data? This data, if you check our first lecture, that data is showing the quantity demanded of gin bitters. So these are some shops that sell akpateshi. And akpateshi is the kill, is the quantity demanded of the gin bitters. The first shop sells akpateshi at 160 bottles. The second shop sells akpateshi at 200. The third shop sells akpateshi at 160. The price is 16 for the first shop, 13 for the second shop, 15 for the third shop. The complement price is 60. The complement is like anything that is used in conjunction with akpateshi, is with gin bitter. It can be chichinga, it can be lime, it can be there. Okay? But beer or any drink, there's a particular complement price. We don't know the complement yet, but that also is a number. Then you have, sorry, this is the price of the gin bitters, and the C is a complement price. Okay. Then you have M. M is the income, the average income of the people in the area. This can also affect quantity demanded though. Then you have location. For example, where the shop is located, will be bought. So whether the shop is located in an urban area or rural area, that will determine how much akpet will be bought. Then you have occupation. You see, the type of job a person does can determine whether he will consume akpet or not. So there are three kinds of occupation: teaching, fishing, and trading. Teaching, fishing, and trading. And then finally, the religion of the person. Muslims, Buddhists, and Christians. Which of them do you think will drink a lot of akbet?
Christians.
Exactly.
Christian.
Now, that is the one I want to just use as an example because the sample elements are three. The levels are three. We have Muslims, Buddhists, and Christians. There are three levels. So there are three groups, unlike location, which is just urban and rural. So because we just did ANOVA, we are going to apply ANOVA on this data set. So what is the question? Bring a hash symbol and let's type a question. Bring a hash. Hash. Hash means you are doing an instruction in the R software. And type what I'm typing here. The question is, does Q, and Q here is quantity demanded. So let me type it. Does quantity demanded of gin bitters, does quantity demanded of gin bitters, into bracket Q, differ? Okay. Does it differ significantly across religions? That's all we are doing. In other words, we want to know which religious group is doing a lot. So that's a question, but it is a hash symbol, so it will not be run as a code. How do you analyze this? How do you address this? How do you, solve this issue? There are so many couple of things that you have to do here. Now, there's a couple of pictures we could have shown. Okay? I'm going to just show you some of them, and then you can check it later. One of them is you can actually do a library search. Do library, type library into brackets, ggplot. ggplot is a package that can do beautiful graphs for you. And you can install this. You can install this. How do you install it? Well, anytime you want to install a package, come to the bottom right here. You see something here called packages. Packages. So if you're installing ggplot for the first time, this is done only once. Click packages here. Then after clicking packages, you do install. You type install. Okay. You type install. And after typing install, you search for the word you are looking for, ggplot, ggplot. If I want you start typing it to come, ggplot 2 in our case, and then you click install. If you have internet, you do that. If you don't have internet, you do it later. I have done it. I have installed it, so I don't want to do it again. Then, once you have installed it, you run it. When you run it at the bottom, it will show blue, which means it has run. You are done. And you can use a certain command here. Yeah, I'm just, in fact, instead of going to the install, one thing you can do is that you can do this command. You can do this command rather, instead of installing, no. You can just do this command, install.packages ggplot, and it will also install automatically. This one. Okay. So after you've installed, we can run something. We can run a graph. Okay, a graph. And this graph is a beautiful graph to show the relationship of the religion, how they change, quantity demanded changes across religion, how Akbateshi changes across religion. The name of the data is gene. So you type gene plot into brackets gene. Okay. After the gene, then you do AES. Okay. This AES is an aesthetic that will tell the R to tell it it will tell the R that these are the variables I want you to focus in this data. So this data here, there are so many variables, but I just want you to focus on kill and then religion. That's all. So you see that here you have kill, which is for the Y, and then for the X, you have religion. However, this data set, it can, you ignore it. You just ignore it. Move on. Just choose the X variable. That is the variable on the X axis. And then the Y is a variable on the Y axis. Then this fill will give it a color. And we want to fill it with a religious color. So we want it to choose its own religious color. And then this geom underscore violin, it is going to create a violin plot. And then inside the violin, it's also going to create a box plot. Okay. When you watch my video, you see the essence of these two. This is the most difficult one I'm trying to do with you. That's all. The rest are all easy. You can check the rest later. So this is going to create a violin plot, and then it's also going to create a box plot. A box plot is always inside a violin plot. The numbers that you see are just the sizes of the plot. The colors that you see are blue. So if it is blue, you type blue. If it is red, you type red. Okay. And then that's it. Once you do that, you just run it, and then you can get a couple of graphs. Let's see whether it will work. Yep, it has given us some graph here. Okay. And this graph is called violin plot. Okay. If you look at it carefully, it looks like a violin, if you know what a violin is. Okay. That is how this plot is. It is giving us violin plot is a plot that combines kernel density, histogram, and box plot. The box plot is what is inside it. The box plot is what is inside it. I'll talk more about this when we come to regression next time. So don't worry too much if you don't understand it. Don't worry at all. I'm just demonstrating a picture. But it just goes to tell you that go through the notes and regarding the packages. Anytime you see something called library, just ensure that you're working. Okay. So this plot is clear. When you check the box plot, the one with the biggest one, the biggest center, you see each box has got a center, a black horizontal line. Which one has got the tallest one? Buddhist, Christian, Muslim. Which one has got the tallest black? The center of the boxes. Which of
The Buddhist.
Check carefully. Not the box, no, but the center of the box is what I'm talking about.
The Christian.
The Christian. You see, the center of the box is the median. Is the median. This one is the median. This one is the median. This one is a median. And the median is a representation of the center. Not just the mean. No. The mean is average. The median is also average. The mode is also average. Okay. The box plot uses the median. And it tells you without even looking at it that the Christians are the one consuming a lot of aquatechi, a lot of gene. Because you can see that is the one with the tallest center of the box. Tallest center of the box. Not the longest box, but the tallest center of the box. The center. The center
Prof,
is yes.
the Muslim one too looks just about the same.
Oh no, let me tell you what I mean by center. Center is this line here. See, that's the center. Look at this one. The center is here. Okay. So when you trace this center leftward, you are tracing it leftward. You see that it's higher. This one,
Okay.
this is the center. When you trace it leftward, it's below 200 quantities. So you can see that the Christians are consuming a lot of above 200 quantities. The Muslims are consuming exactly 150 quantities. But the Christians are consuming a lot. So sometimes I draw this graph in an exam and I tell you that using the graph, tell me who is doing more, who is doing less, okay, and who is doing that. Like I said, we do deep thing. But the most important reason why we are here is to check whether there is a statistically significant difference in the quantity demanded of gene bitters across religion. So let's check. So you write this command. You write R. R here is simply talking about results. You can even use your name. Okay. So you write R, and then you write AOV. AOV is simply ANOVA, a short form for ANOVA. And then we have typed Q. Okay. Q here. Oh, by the way, if you are ever doing this and it doesn't work, you let me know. I don't expect you to be able to do it now. You can do it later. So look at this. Q, you type Q because the Q is the thing we are going to check. We are checking the quantity demanded, which is a Q, the quantity demanded of gene bitters. Then you have a Greek symbol called tilde. This is changing across religion. So religion was represented here by REL. You can see it in the data set, REL. So this is saying that I want you to calculate the ANOVA for religion, for quantity demanded across religion. The name of the data should be gene, and then summarize the results for me. That is what this one is doing. It will calculate the ANOVA for you. So we run it. At the top, you click run, and then when you run it, you get this beautiful result. It's beautiful. Now, you can see that the F statistic is 44. Okay. It doesn't give you the critical value, but the most important thing it will give you is the p-value. Please look on the far right here. The PR stands for probability. Probability is a long word for p-value. Probability value means p-value. Write it down. Probability means p-value. So PR is the probability. Now, write this down. Write this down. I think you guys have said it before, that whenever the p-value, we said that the alpha value and the p-value, which one do we wish it is smaller?
The p-value.
The p-value.
Okay. Now, all the software use alpha of 5%. So even though you don't see it written, the software behind the scene is using alpha of 5%. So we know that the alpha here is 5% for this example, this religion example. But what is the p-value here? Well, the p-value, if you want it, you come and check here under the PR. Okay. And when you check it, the value of the p-value is written down here. It's a little bit confusing, because it's written E minus 10B. But that E minus 10 is nothing. Who can tell me what that E minus 10 means? It's written 1.45 E or exponent minus 10. What does that mean?
0.0000000.
Infinity.
It's not infinity yet.
Oh. It's raise the power 10 in a negative
0.9145.
Good. So it simply means that there are 10 zeros before the 1, 4, 5. So watch it. It means there are 10 zeros before. Then after the first zero, you just bring a dot. But it simply means there are 10 zeros before the, 1, 4, 5. That's what it simply means. Which simply means that somebody is just interrupting. Okay. Which simply means that this value simply means what value? It simply means 0. Okay, that's what it simply means. Because 0.90145 is basically 0. So we can conclude that our p-value is what? Is 0. So if the p-value is 0, what does it mean? Or if the p-value is less than the alpha, what does it mean? Write this down. Reject the null hypothesis whenever the p-value is less than alpha. Reject the null hypothesis. Reject the null hypothesis when the p-value is less than alpha. Reject the null hypothesis when the p-value is less than alpha. Reject the null hypothesis when the p-value is less than. So here, the null will always be that there is no difference. Don't forget that. Write it down. You see, the most important thing is writing everything down. The null will always be that there is no difference. There is no difference in the quantity demanded of gene bitters across the religions. That's what the null will say. There is no difference. Master, there is no difference. But graphically, we have already even seen that there seems to be some difference. But graphical is not enough. We need a statistical torture. And statistically, whenever the p-value is less than alpha, then we can reject what the null is saying. The null says there is no difference. Looking at our p-value, it is 0. Truly, it's less than 5%, which is the alpha. Therefore, we can go ahead and reject this null hypothesis, which was saying that there is no difference. And we can now conclude with statistical macho that there is a significant difference. Sure, there's a significant difference in the mean salaries of these three MBA groups. So, on the basis of this, we have to conclude that does religion determine, does a type of religion affect quantity demanded? What would you say?
Yes, it does.
Yes, it does. Yes, it does. The type of your religion will affect the quantity demanded. Okay? So yes, it does. The type of your religion will affect the quantity demanded. And in this case, we can conclude that which religious group consumes less aquatation?
Muslims.
Muslims. It is clear graphically. It is so clear graphically. Now, if you really want to, suppose you didn't have the graph and you want to know which religious group, has got the highest, one thing you can basically do is you can find the mean. You can find the mean. Excuse me. You can find the mean of the quantity demanded, which is what I'm doing here. Why do I get this symbol? This tilde symbol. Okay. So I'm just going to do quantity demanded across religion. I'm typing this here. I'm just trying to find the mean. Suppose you don't see this well, or suppose you are not given this. Okay. You type quantity demanded tilde sign mean, and then you run it. Okay, this one doesn't show the result because I may have. So let me put gin dollar. So you can put something called gin dollar for the religion. No. Patience. Okay. Let me just quickly check. Oops. Let me just quickly check how to get the mean. You will not have to write this, but when you are doing group assignment, that one you do a bit of this. So just how do you put it? Be slightly used to, finding them. Oh, I'm trying to just get something for you here. Here, REL, the name of the data. Okay, good. Let me just show you something. Apparently, I wasn't even showing the results. All right, so I decided to code something quickly here. So this is result, just watch something. All right, result. Let me delete this because this one wasn't. Suppose I want to find the mean, okay, because the whole question was about the mean. You just write result equal to, this thing can always be equal to, let's do equal to, result equal to aggregate, then you write the quantity demanded, which is the numerical variable. And then the types of religion, you write REL, because that was the name that was given to it. Okay. If I just highlight this, it will show the name of the data down there. That's it. So you see the name of the data down there. And then I just write the function. I want you to give me the mean. That's all. And then I run this. Once I run this and say, show me the result, print the result, it will give me the mean for each of the religions, the quantity demanded each religious group is consuming. And when you look at the numbers carefully, you can now see that Christians are consuming a lot, followed by Buddhists, followed by Christians, Muslims. So you can, even without a graph, you will always be able to use this to find it. But when we come next week, I'll show you proper way of finding all of this. But this is just to endorse the fact that whenever you have a data set, you can statistically check whether there is a significant difference across of a particular variable across groups. It doesn't matter whether the groups are 2, 3, 4, 5, or 10. You can check whether there's a significant difference in the election results across NDC, MPP, GCPP, whatever it is. You can check whether there's a significant difference in anything across different groups. You can check whether there's a significant difference in the profit of banks that are state banks, foreign banks, domestic banks. You can check whether there's a significant difference in the population sizes of, Greater Accra region, Ashanti region, Central region, or whatever region. You can check. You can always check whether there's a significant difference across anything. And that is just an example of what we have done. Ladies and gentlemen, that brings us to the end of the entire caboodle. Oh my goodness. That brings us to the any question? Any question?